have this afternoon to really cover a few elements of the technology with you. First of all, I'll just do a very brief introduction into ExaGrid, the company. I'm not even going to ask which one of you have heard of ExaGrid before, because I'm assuming it'll be a very small show of hands, so I will cover the company in a small amount of detail. But then really focus on not just the technology, but why we do what we do. Because one thing that generally people will believe is that if you look at disk-based backup with deduplication, all things are equal, everything is the same. When fundamentally, if you look at the main storage vendors, that's the case. But if you look at where ExaGrid plays, we have a very differentiated way of doing things that really adds a lot of value to a Veeam environment, as an example, and many other environments out there. So we'll cover that in a little bit of detail. Any questions, please stop me as we go through the presentation, and I'll be happy to take any questions as they come up. So just briefly in terms of company introduction, ExaGrid is an organisation, we've actually been around since 2002, primarily focused in the US. Our headquarters on the east coast of the US, based just outside of Boston. But if you look at our current generation of technology, our current product set, that really dates back to around 2006, early 2007, so very established in terms of the code base and the architecture that we have. As a result, we've now become the largest independent vendor in the space. That's something that we are continuing to grow with. And one of the reasons that we are successful in the market today is the fact that we do have a level of differentiation that's architectural differentiation. It'll become clear as we go through the presentation as to what that differentiation is, and I'm not going to focus on it in too much detail here. But as a result of that differentiation, we have now won a vast array of different industry awards. For those of you that monitor the Gartner Magic Quadrant, there is a Magic Quadrant that plays in our space, and we are the only visionary in the Magic Quadrant. So that again sets testament to the fact that what we do well. Over 10,000 systems installed globally, and another thing that people find extremely unusual is that we have over 350 referenceable customers. And that's where an organisation has taken the time to explain the problems they had with data protection, what they deployed from ExaGrid to solve those problems, and the results they saw from doing so. Many of those are Veeam-based, and there are other customer success stories out there that are just downloadable from our website. So it covers all verticals, it covers all backup applications, a great view of what we do and the fact that we do it well. So it's interesting, something that was mentioned earlier, in that people's needs have changed when it comes to data protection, but actually the requirements have stayed the same over maybe 60 years, which is pretty much how long tape has been around. The requirements haven't changed. The importance of each of the requirements is really where the shift has taken place in data protection. So if you go way back where people were using tape, they wanted to find ways of automating backups. They wanted to find ways of shortening the backup window. Then disk came around for disk staging, so those requirements became easier to meet, and people wanted to focus on ease of use. But now, primarily actually, if I'm honest, through the evolution that Veeam has introduced into the market, the main focus on data protection today is around recovery. And it's become the case that the only way you can get fast backups, but more importantly the fast recoveries, isn't from tape anymore, it's from disk. But people want to reduce the amount of disk being used for backup purposes. So as a result, very quickly people decide that I'm not just needing to now deploy disk for data protection, but importantly I also need to deploy deduplication. And for those of you that are not familiar with deduplication, every time you do a backup, you're copying the data to another storage location. The more copies you make, the more disk you need. But within that data set, there's a lot of redundancy. There's a lot of data that's just a copy of a copy of a copy. So with deduplication, what you're effectively doing is reducing the amount of disk needed for backup or for data protection, because you're only storing, after the backups take place, the unique data. It's a great way of getting long-term retention with a minimal amount of disk space. There is a disadvantage, though, in deduplication. Deduplication, whilst it reduces the footprint of disk needed, is a very compute-intensive process. It takes compute power to reduce the data set to the storage. So one thing that I see commonly in the market is deduplication. If people have had the benefit of backing up to disk today, and they move to a deduplication appliance, they can immediately lengthen their backup window, they can increase the restore times, not decrease them, and they can certainly add a situation where things like tape copies could take a long time. But again, focusing specifically with Veeam, you could see situations where instant VM recovery becomes unusable because of the time it takes to recover where deduplication has been involved. So there are a number of different ways in which you can approach deduplication. Primarily, we see three approaches in the market: deduplication in the backup software. One thing that existing Veeam customers will be familiar with, and many other backup solutions out there have the ability to do software-based deduplication. It has a fit in the market, which I'll talk about shortly. There's also a number of storage vendors out there do deduplication in line, as it's termed, and that's with an architecture that scales up every time you need to add capacity, you add disk. It sounds sensible, but there are better ways of doing it. And the third option you see here is what we have as a technology, which is a landing zone architecture with a scale-out approach. And if you look at where the market is today, we are the only vendor doing what we do. Everybody else has taken the middle option, the inline option. First of all, just covering backup software deduplication, an inbuilt feature of many of the backup applications is the ability to just switch on deduplication to any straight disk array. But with backup software deduplication, and I've already mentioned that deduplication is compute intensive, the software vendors take a large block size to identify the duplicate data because it's on a general purpose server running many other tasks. And by taking that large block size, you can't identify as much duplicate data as you would if you take a smaller block size. But the reason you don't take a smaller block size is your general purpose server that's being your backup server isn't as powerful as the general app servers out there, so you end up having to trade off performance for the storage required. The larger the block size, the more storage you need to store the data. So ExaGrid versus straight disk, a very clear message. 4 weeks retention on disk or less, and actually straight disk has a good fit. 4 weeks retention and more is where ExaGrid plays extremely well to be lower in cost than the cheapest of disks that an organisation could procure. So that's a very straightforward way of working out the fit between straight disk and ExaGrid. And Veeam does a good job of deduplicating data. There's also a perception in the market that says, well, I'm using Veeam dedupe today, why would I want a deduplication appliance? With ExaGrid specifically, we can deduplicate the data that Veeam has already deduplicated. So you get an overall greater effect of deduplication and ultimately less storage footprint needed. And as a combination of doing that, again, the cost of ExaGrid versus straight disk can be quite compelling in that sense. So for the remainder of the presentation, I'm really going to focus on why we do what we do and how it's different to those other solutions out there. And as I mentioned, there's one way of doing deduplication out there in a storage appliance that's termed inline. It does exactly what it says on the tin. It takes a data set, and in line between the media server and the storage, it does deduplication. So there's a number of operations that are taking place on the data that says when you write the data to disk, at that point the data will have been deduplicated. So it's a way of getting the data into its smallest possible footprint, but it comes at the cost of performance. Now, 8 years ago, before recovery techniques became important, you would find that that was an acceptable way of doing things because that would still allow you to meet your backup window. Now when it comes to recovery, that's really where the inline processes get in the way of getting what you require from your recovery time objectives. And why that is as soon as the backup's finished writing, all you've stored is the unique data. You don't have a full copy of data to work with anymore. So by just having the unique blocks that are stored on the file system, any read-back operation, whether it's a restore, a recovery, a take copy, even a booting a virtual machine, it takes a considerable amount of time to have those operations taking place when you're having to put it all back together again. And one way in which I describe it, which is an analogy that makes sense, is it's like a jigsaw puzzle. You're taking all the discrete bits and you're putting them back together to put the puzzle of deduplicated data back into its full format. Now, just focusing a moment from a recovery point of view, most organizations actually recover from the most recent version of data. You don't go back a week or a month commonly. Commonly, it's the most recent version of data you'd be recovering from. I'll explain how we fit there in a few moments. So, for those of you who have inline deduplication appliances, for those of you that are looking at them, I'm not saying they do a bad job, they actually do a job of reducing the data, but it does come at the cost of performance. And that's really where our architecture was focused. In one of the things we had is the benefit of being newer to market. We found a way in which you can improve the performance without actually affecting the overall ability to do deduplication of data. So what do? We have what's termed the landing zone architecture. That landing zone architecture gives all of the benefits of straight disk without the disadvantages of deduplication getting in the way of that performance. What that means is that we're providing an area of landing zone that's sized on a one-to-one relationship with the amount of data that you're backing up. Now, in the first instance, normally the first comment I would get on the fact that we're providing that one-to-one relationship landing zone to source data is that, wow, that must be very expensive compared to the inline devices. We are providing more disk, admittedly. The perception says it should be higher in cost, but the reality is it's not. The reason is that we're not under pressure of the backup window. So whilst we're providing more capacity, actually we're having less compute power in the unit to go through that deduplication, and we're not under pressure of that backup window at the same time. So it can actually be, in most cases, lowering cost than the inline way of doing things. We also do deduplication adaptively. So what that means is that, and I'll give you some specific examples, one of our models, one of our systems can take a 32 terabyte full backup, just as an example. And that system has a rated ingest capability of 7.5 terabytes an hour. So if you're backing up to that device, you get 7.5 terabytes an hour and you're achieving that sort of capacity, your backup window is 4 hours or less. If you're not getting that maximum capacity because the environment's not capable of doing so, quite simply we'll be doing deduplication at the same time as you're ingesting. So there's an ebb and a flow to the way in which deduplication works, but at all times we favour the ingest performance, and deduplication is done secondarily. But with all of our units, whether a customer's got 1 terabyte of data or 800 terabytes of data, the backup window you should expect, if you're able to achieve our maximum capacity with the environment you have, would be 5 hours or less. Quite a compelling way of protecting some significant volumes of data. Pretty standard things like global deduplication we have, but fundamentally one of the biggest differentiators we have, besides the landings and architecture, is the fact we have a scale-out grid. For those of you that are familiar with the deduplication appliance world, if you look first of all at primary storage, every single storage vendor out there has a scale-out architecture for primary storage, but they don't have it in the deduplication appliances. Whereas it's more important in the deduplication appliances because there's a lot of number crunching taking place to do the deduplication in the first place. So just in summary, in terms of what we're trying to achieve with the way in which we do things, is faster backups because the deduplication algorithm does not get in the way of the ingest. Faster restores because the landings are actually holds the most recent copy of data. So when you want to do a take copy or an instant VM recovery or browse to an Exchange database to be able to do single mail recoveries, no rehydration needs to take place from that most recent version of data. And that's more than 90% of the time the version that you'll be recovering from. And I will focus on that just in a little bit more detail a little bit later. And I'll also talk about the grid in a bit more detail. So we have a solution that works with a variety of different data types. We don't provide a software solution, we're purely a backup storage appliance. There are many different backup applications out there that do what they do really well, so our philosophy is that we will work with those 20 plus different backup applications. But importantly, we can work with multiple different applications at the same time. And it's become extremely common that most organizations today, unless they're 100% virtualized, most organizations run 2 backup applications. So one solution with deduplication for multiple different data types to reduce the footprint needed for backup purposes. It's a very straightforward to deploy system. The best way I could describe the device that we have is it's a network attached storage device. It connects to the network using one or multiple single gigabit Ethernet connections or multiple 10 gigabit Ethernet connections that would then be used by the backup servers or the media servers or the proxies to communicate and write the data to us. You can do take copies outside of the backup window, and you can do replication between sites. So from a replication point of view, we have a byte level deduplication algorithm that at the same time you're doing the deduplication, we can replicate a data set from one machine to another machine. And again, I'll go into that in a bit more detail a little bit later. But so in terms of deployment, very easy and very low risk, because all you're really doing is installing a device, booting it, giving it some IP addresses, and then all of the day-to-day management is done from your existing backup tool. And that's where you control backups and recoveries. This is just a storage device that has some clever bits of software built into it, so it's very straightforward. Deployment generally takes under an hour to get a system integrated into the environment, and then all the configuration work, as I say, is done from the existing backup tool that you'd be using. So just moving on and talking just briefly about recoveries, and this is really where our integration with Veeam, or benefits of integrating ExaGrid with Veeam, start to become strong, in that as you want to keep more and more data on disk, the amount of disk needed dictates that a deduplication appliance is required. But then if you look at typical deduplication appliances, particularly the ones that do inline deduplication, you end up in a situation that you need far more time to recover data than you would if it was straight disk, as an example. One thing that most organizations buy Veeam for, or one of the reasons, is instant VM recovery. And instant VM recovery, as it was described earlier, boots the virtual machine directly from the backup target. Now, booting a virtual machine is a very random I/O type pattern. restoring a virtual machine can be a very serial I/O pattern. So you can find actually, when you try and boot a virtual machine from a deduplicated copy of that virtual machine, you can find it takes longer than a restore took in the first place because of the patterns involved in doing so. And generally, and I've witnessed it myself, it takes a lot longer than 15 minutes, which is the typical RTPO type time that Veeam would be quoting, a lot longer if you want to do any volume of data recovery around instant VM recovery from a deduplication appliance that hasn't stored that data in its entirety. And that's where our architecture really does fit so well with Veeam, is the fact that we have the landing zone with the most recent version of data stored means that you can spin up a virtual machine in seconds to minutes. You can remotion it back into production. You can do Sure backup in a very timely manner because of that full copy of data being stored. And if you still do use tape copy functionality, you can still do tape copies directly from the landing zone. The landing zone will always hold the most recent version of data. And that's, as I said earlier, the version you'll be using 90% plus of the time. So that's the first way in which we integrate very well with Veeam. Another reason the integration is so strong is we've actually recently brought Veeam functionality, if I describe it that way, into our system. So one of the components that exists within the Veeam environment, within the backup proxy, is called the data mover. The data mover is something that now can exist within the ExaGrid device. So it's turned from a co-development effort, the ExaGrid Veeam Accelerated Data Mover, and that data mover now exists not just in the backup proxy, but we also have that functionality sat at the ExaGrid level. And that brings a number of advantages, and it's worth mentioning for certainly, we call half of the audience is an existing Veeam customer. The benefits of the data mover can be quite considerable, particularly when they run inside a storage appliance such as ExaGrid. So first of all, by using the data mover protocol, we don't need to use CIFS or NFS anymore. We actually use the data mover protocol to get data from backup proxy to ExaGrid. And there was a recent enterprise strategy group test that did a comparison between ExaGrid without the data mover and ExaGrid with the data mover. The performance difference was roughly a 40% improvement in performance by doing nothing but changing the protocol. CIFS is a very chatty protocol. Using data mover instead did give us some performance benefits. But also, the data mover in conjunction with the landing zone, and I have a few slides coming up on it shortly, gives other benefits around backup copy jobs and synthetic full backups to actually alleviate some of the load that's put on the infrastructure by doing those sorts of tasks on a system. I'll cover those in a few moments, as I say. But also, I've mentioned it once, but I will mention it again, the fact that we can deduplicate the data that's already been deduplicated by Veeam and add further deduplication to it allows you to get the best of both worlds. You get performance and you get data reduction. So typically, we will see, I know some of you are already using Veeam, we will typically see Veeam do about a 50% reduction in the storage through its inline deduplication and compression. So we recommend you leave that switched on. We don't ask you to compromise between do we do it in the hardware or the software. We say do it in both places. That's the best way to achieve what you need to. So as a result, I mentioned earlier we size based on source data. That means if you've got a 10 terabyte data set, you'd expect Veeam to write about 5 terabytes into the ExaGrid landing zone. So then when you start writing incremental backups too, you end up with full and associated incrementals all in the landing zone at the same time, and still have enough storage available to have another full copy of the data, which is where things like synthetic full backups and backup copy jobs can have a huge benefit when it comes to having things done in this way. And typically we can be adding anything from 3 to 5 to 8 to 1 in addition to Veeam's deduplication retention dependent. So just in terms of some of the backup data flows, or illustrating where the data mover can help, having it sat within the ExaGrid, I'll just build this slide up. Generally, if you want to do something like a synthetic full backup, first of all, let me just rewind. Why would you want to do a synthetic full backup? Many organizations don't want to do full backups on a regular basis. And a full backup can be obviously 100% of your data volume. An incremental backup can be between 5 and 10% of the data volume. So people like to do incremental backups. The more incremental backups you do, the longer restores will take because you have to stitch data back together again between incrementals and full. So by doing a synthetic full backup, you're only taking an incremental backup from the hypervisor, but then you're getting a new full backup created within the storage environment. So you're putting the load of creating it into the storage environment itself. Generally what will happen is when you take the incremental backup into the storage appliance, if you move ExaGrid to one side for a moment, to then create a synthetic full backup in most of the solutions out there, you have to read the incremental, and the full, and any other incrementals that are associated with that full, up to the backup proxy, which goes over your production network, or certainly your backup network, and then right down over that network, the full backup. And that, I mean, when you've got tens of terabytes of data, that's a lot of data that's traversing the infrastructure that should be avoidable, and can be avoidable with an ExaGrid way of doing it. With our way of doing it, quite simply, having the data mover functionality sat inside our system means we can take the incrementals and the associated full and create the new full completely inside the ExaGrid unit. There's no network transfer that needs to take place, reading or writing, back and forth to that backup proxy. The other benefit of doing this within the ExaGrid unit is now you've got a new synthetic full backup you can recover from, and it's sat in the landing zone. But having that synthetic full takes pretty much zero space in the retention zone, which is where we keep the deduplicated data, because that synthetic full is all data that we've seen before. We've already seen all of the incremental backups and the full backup that synthetic full was based on. So you've got the benefits now, landing zone data to recover from, but no further storage needed in the retention zone. Similar to backup copy jobs, we can again avoid the backup proxy, so data mover to data mover communication, but it's Veeam that's doing the replication in that sort of scenario. So again, it's a powerful way of reducing the need on the backup proxies. For those of you that like to have virtual backup proxies, it makes it so much easier too, because you're not putting too much of a load up at that virtual backup proxy by having the data mover functionality that, as we mentioned down in the ExaGrid device. And backup copy jobs with WAN transfer is something you can do directly storage to storage. Before I move on and talk about our grid architecture in a little bit of detail, does anybody have any questions at this point, or everybody happy so far? I didn't bring any gifts, but I see I've been left so I can throw it if I need to. So let's just chat about the grid. This is really one of the key factors to our success, is that the ability to maintain performance as data scales is key. I'm sure most of you had situations where you deployed a new solution years ago, that solution was fine day one, and over time the backup and the restore times grew. Naturally they will, whether it's tape or disk. And if you look at all the other solutions out there, they have a scale-up architecture that says, I'm going to start with a front-end controller, and that front-end controller has a certain amount of processing power, disk, and bandwidth within it. Now, when you deploy that controller, that fixes the performance for the lifetime of the product, because that's the bit that controls how quickly you can inject, how quickly you deduplicate, and how quickly you can rehydrate, how quickly you can recover the data and put it back together again. But as data grows, you're obviously going to need more capacity. So as you need more capacity, you put disk shelves behind the controller, so generally an accepted way of doing things. But if you go from 10 to 20 terabytes of data to backup, or 20 to 50, or 50 to 100, and generally people accept that data is doubling in a 3 to 5 year period, your data will grow. And as your data grows, with this kind of approach, the backup window will grow, and the restore times will grow. To the point where in certain circumstances, you can only put so many disk shelves behind a certain controller, and you can't go any further, so you have to do a forklift upgrade to the bigger, faster controller that supports more disk. But also, just to give you some context, there is a device out there from one of our competitors that can ingest at 5 terabytes an hour. And it can start at 30 terabytes, and it can grow to 130 terabytes. Now, with 130 terabytes of data and a 5 terabyte per hour ingest rate, you kind of outspeed 80 terabytes. It doesn't matter if you go to 130, you have your backup window by the time you get anywhere near kind of that 80 terabyte type limit. But also, to try and avoid the complexities of the inline algorithm, you see some options out there that have software features that you can install on your media server to do some pre-processing. We have no such feature because we don't need to offload some deduplication to a media server when we're not under the pressure of the backup window in the first place. So those boost-type technologies that boost the performance, from, in that example, used from 5 to 13 terabytes an hour, that's coming from your media server. That's not the place to do it. Our architecture is very different. Every time we add disk, we also add compute power. It's a sensible way of scaling, because it means that every time the data grows, you're adding everything you need to be able to not just ingest the data, but also tape copy it, recover it, to maintain a linear backup window and restore times. You can put different capacities of machine into the same grid. You can put different generations of machine in the same grid. And that's one thing that you'll see across some of the case studies that we've got on our website, is we do have customers with machines that are 6 years old in the same grid as brand new machines today. Now, there's an argument to say at some point maybe they do a trade-in on some of the equipment, but you don't have to. You can have different generations of technology running in the same machine at the same time with equipment that wasn't even on the roadmap those 5-6 years ago. So it's a nice, easy way of protecting the investment and ensuring there is no technology obsolescence as as the data grows. Now this is a very busy slide I've got coming up. Just a few points I wanted to draw from this particular slide. First of all, we have a variety of different product sets or products in our product range, starting with an entry-level unit. It's just a 1 terabyte landing zone, so it's a very easy to adapt entry-level unit. And then we go 2 terabytes, 3 terabytes, 4, up to the 32,000E, which is a 32 terabyte unit. So very easy to right size and deploy what you need for today without having to oversize too much for the future. You can put up to 25 machines in the same grid. And by doing so, you can just grow as you need to and when you need to. Generally, so if a customer has a 64 terabyte requirement, we have 2 32 terabyte units, and there's still plenty of functionality then to grow up in the future. You'll see the performance numbers listed over here. Each of the units can ingest the rated amount of data in 5 hours or less. 5-hour backup window doesn't matter, as I said earlier, whether it's 1 terabyte of data or 800 terabytes of data. And that's a slightly separate product range. We have a product range that's encrypted. The data on these is encrypted as it's sat at rest, but also you'll notice the performance numbers are identical. We've done an approach that says hardware-based encryption is really the only way to do it, because if you use software-based encryption and you're doing deduplication and you're doing replication, all the other tasks these devices are doing, then the performance can be impacted quite significantly. So we do truly believe we've thought of the ways in which we give customers what they need around performance and also scalability. And the grid architecture is something that none of the other players in this mid-market have, and the scale-out approach to data protection. Just to explain it with some specific numbers, and there certainly isn't a way of focusing on the competition, but I think this is an important view of how that grid architecture really does make a difference performance-wise. This is, I guess, the mainstream product you see out there, the EMC product range, and it comes in a variety of different variants. If you fill a 4200, you do a forklift upgrade to 72, and fill a 72, a forklift to the 95,000 as an example. But each of these, and these are datasheet numbers, has a rated performance, but it doesn't matter where you are in the range, the performance is always the same. As we grow our grid, you're adding 7.5 terabyte chunks as you grow in terms of the performance capability. So by doing it that way, as you get to somewhere around this area, if I use this area, you tend to find we're around double the performance, about half the cost. And that really is quite a powerful combination between those two types of products. Lastly, in terms of functionality, we also have a replication capability. Replication and deduplication are pretty much the same process. In the deduplication is identifying the changed bytes. We store them locally and we replicate them remotely. Now, if you're doing ExaGrid replication, it's retention zone to retention zone that's being replicated. So that means on the secondary site, you can have a system without a landing zone. So as an example, a 10 terabyte unit on the primary site, which is 10 terabytes of landing zone and 10 terabytes of retention zone, can be matched by a 5 terabyte unit at the DR site, and you turn the 5 terabytes on that of landing space into retention space to match the primary. By doing it that way, almost half the cost and the capacity of the system needed for DR. But you can also take a hybrid approach. You can use our replication for the data that's less critical in terms of integration with Veeam, but you can use Veeam's replication to a landing zone on the remote site for the data you would want to spin up in the event of a disaster, and vMotion back into production at that DR site. So quite flexible, you can use both modes of replication rather than one or the other. You don't have to make that choice. Also standard features like WAN encryption and bandwidth throttling are built in. And we can take a multi-site topology where you can take up to 15 remote sites, replicate them into a central hub, and the central hub can replicate out to one of the remote sites. I've talked about a number of different features, and particularly software options, as we've gone through the presentation. We've talked about replication, we've talked about management, we've talked about the accelerated data mover. None of those options have a cost associated with them. By definition, if you have one unit, all the licensing you need comes with it. 2 units includes replication, and so on and so forth. So there's no complexity around trying to do a pick list. You just buy a product with or without 10 gig of Ethernet and then support. It's no more complicated than that. And that's it. In terms of capabilities, in terms of what we do and how we do it, I won't go through each of these bullets one by one because I know we are just a little bit behind the original schedule. Just in summary, we built a product around performance, scalability, but also the ability to make sure that you don't have to make any difficult choices as far as the storage is concerned. You focus on the architecture out there, the topology you have, the backup data movers you use. ExaGrid can be that common platform to offer the performance and scalability regardless of what you've got sat on the front end. Any questions before I hand over? Oh, it's break next, isn't it? It's a break. Any questions? So So I'm going to be around all the evening or afternoon, so if any questions you wanted to chat around one-on-one, I'll certainly be around. Thank you for your time, and hopefully we'll speak again a little bit later. Thank you.